Hey there, so in this video we're going to be looking at Descartes' rule of signs, and this rule of signs is going to help us to narrow down our choices for our list of possible rational zeros of a polynomial. So if we have a polynomial, let's say for example f of x is equal to 3x squared minus 2x plus 3. Actually, let's make this a little bit more interesting. Let's do 3x to the fourth minus 2x cubed plus 5x minus 3. We'll do that polynomial. So we have this polynomial here, and we want to start to figure out what its zeros are. And so instead of actually starting to factor this, before we can even try and factor this, we want to start to decide what are some of our possible zeros. So this rule of signs is going to help us decide how many positive solutions we'll have and how many negative solutions we'll have. So in order to check our positive solutions, all we have to do is count the number of sign changes that we see between each of the terms. So for example here, we went from a positive 3 here to a negative, so that's 1. And then we went from negative to positive, so that makes it another 1, so 2 so far. And then from positive to negative, that's another 1, so that gave us 3 sign changes total. So that means we'll have 3 positive solutions, or to take into account imaginary solutions, what we do is we subtract 2 from what we got. So in this case, 3 minus 2 is 1. So we'll either have 3 positive solutions or we'll have 1 positive solutions in this case. To figure out how many negative solutions we'll have, we want to replace all of the x's with a negative x and then simplify. So if we're looking at this polynomial, I will plug in negative x, which will give me 3 times negative x to the fourth minus 2 times negative x cubed plus 5 times negative x minus 3. Simplifying this will give me a positive 3x to the fourth. This will become a negative x cubed with a negative out in front, becomes positive 2x cubed minus 5x minus 3. Now that we've simplified, we're going to count our sign changes again. So this is a positive here, and that goes from positive to positive, so that's not a change. And then we go from positive to negative, and that's 1 change there. And then it goes from negative to another negative there, which means that there's only been 1 sign change. So therefore, we're only going to have 1 negative solution in this case. And since we can't subtract 2 to give us a negative value, there can't be a negative number of solutions. Therefore, we're only going to have 1 negative solution in this case, and either 3 positive solutions or just 1 other positive solution. So Descartes' rule of signs helps us to narrow down how many solutions we're going to get when we take that polynomial and we set it equal to 0 and start to solve for x's. We're going to know that there's going to be a total of this many positive solutions or that many negative solutions. So we'll do another example here. To check the positive solutions, we're going to see the sign changes. So it goes from positive to negative, so that's 1. Negative to positive is another 1. Positive to negative is another 1. So there's going to be 3 or 1 positive real zeros or positive solutions. Remember, your zeros are the solutions to setting your polynomial equal to 0. And then we're going to plug in negative x to see how many negative solutions we'll have. That's going to become negative 3x cubed minus 5x squared minus 6x minus 4. And we see here that there is no sign changes. We go from negative to negative to negative to negative. Therefore, we're going to have 0 negative real zeros. All of our solutions are going to end up as positive solutions. So that's Descartes' rule of signs. It helps us to narrow down how many zeros we're going to have from our polynomial. Our next test here is called the rational zero test. Sometimes it's also called the rational root test. So what this test does is it takes any polynomial and it helps us to decide what would be our possible zeros. So what we want to do is take a look at the last constant of the polynomial and the leading coefficient of our polynomial. And so that constant at the end, that a naught that I highlighted right here, that is going to represent p, and p is always going to be going into the numerator there. And our leading coefficient, right here, is going to represent q, and that's always going to go in the denominator. So I'm going to take a look here at an example. We have our constant at the end. That is going to be our p. And we have our leading coefficient, which technically is a 1 right there. That is going to be our q. So to find all of our possible rational zeros, what we're going to do is we're going to find all of the factors of those two numbers that we just looked at. So we look at the number 1. What are all of the factors of 1? Well, we have plus or minus 1, essentially. We can have plus 1 times plus 1, negative 1 times negative 1. So we're going to have plus or minus 1 as one of our factors for that. And then we're going to divide that by the factors of q. So again, our factor or our coefficient here is 1, so our factor is going to be plus or minus 1. So what we can do is we can start to separate these. So you want to think, here's this positive 1, and it's divided by a positive 1. That gives us a positive 1. Then we have a positive 1 divided by a negative 1, so it could also be a minus 1. And that's pretty much our only solutions. If we do negative and negative, that's going to become positive, which we have there. And then negative and positive will give us negative. So these right here represent our possible zeros. So x could equal 1, could also equal negative 1, but we'd have to use synthetic division or some other test to make sure that these are actually zeros of the polynomial. We can also use Descartes' rule to decide how many positive and negative solutions we might have. So if I look here and I try and apply Descartes' rule for positive solutions, I see that these are all positive. So that means there's no sign change. That tells me that I'm not going to have any positive solutions. So Descartes' rule, together with this leading coefficient test, this rational test, tells me that most likely negative 1 is going to be my solution for this polynomial. 1 here is a positive number, and Descartes' rule tells me I'm not going to have any positive solutions in this case. So let's go ahead and do this next polynomial. I'm going to do the rational zero test. So that means I'm going to look at this back constant, and this front coefficient. You'll want to make sure that you have them in order always. And so my factors of p are going to be factors of 3, and factors of 3 are, well, let's do this in order, 1 and 3. Those are the only two numbers that we can multiply together to give us a 3. And we want to make sure that they're both positive and negative. Q is going to be the factors of this leading coefficient. So the factors of 2 would be 1 and 2. So now I'm going to separate this out. So I know that I have plus or minus 1 because 1 divided by 1. I know that I'm going to have plus or minus 1/2. Plus or minus 3 over 1, which is just 3. And then plus or minus 3 over 2. So you're doing all of the possible combinations of these 4 numbers that we could do. And it gives us our total number of possible solutions. So in total, we have 2, 4, 6, 8 possible zeros, because remember, plus or minus counts for 2. So we have 8 possible zeros. We can try and use Descartes' rule of signs to narrow this down a bit. So I see that there's only one sign change here. This plus is not supposed to be there technically, I suppose. One sign change from there to there, and then another sign change from there to there. So I have 2 sign changes, which means there are possible 2 or 0 positive solutions. If I do the negative of this, so I plug in a negative x, just like that. That's going to simplify to negative 2x cubed plus 3x squared minus 8x plus 3, which gives me a total of 1, 2, 3 sign changes. So I could have 3 possible negative solutions. So see how that narrows it down just a bit, because we saw here that we had a total of 1, 2, 3, 4 positive solutions and 4 negative solutions. So it means that one of these negative solutions is not going to be a factor, and 2 or all of these positive solutions may or may not be zeros. Sorry, they may or may not be zeros. So that is how we can use both of those tests. These right here are the possible zeros. And this is using Descartes' rule to see how many zeros we may or may not have. And that concludes